This meeting is being recorded.
For problem 17 in chapter 4, we're told that this compound shown below here has been evaluated or studied using computational software. So its three-dimensional shape was analyzed to find the most stable structure. So we'll discuss, or we have discussed, if you watch the PowerPoint video on section 4.7, how to do what's called conformational analysis and determine the most stable or predicted most stable structure. So we're asked here to provide an IUPAC name for our compound and then also draw the Newman projection as viewed from this angle indicated. So let's take a look how we can do this. So if we were to identify the parent here, that's always our step one, to ID our parent. There are multiple paths that we could have taken to give us a five-membered longest carbon chain, but we also need to make sure that we have the one with the greatest number of substituents. So that's what I have highlighted here. So let's number this 1, 2, 3, 4, 5. So our parent is a pentane, our five-membered carbon chain. Now we need to identify and name our substituent. So on carbon 2, I have a 2,2 with my methyl, but I'm gonna actually not finish that yet because I see that on carbon 4, I also have two methyl groups. So I'm gonna give locants for all four of these and then call them collectively tetramethyl. And we have one more substituent on our carbon 3, and that will be a 3-ethyl. So if we were to put this all together, we would name this by alphabetizing our ethyl substituent first. That would be 3-ethyl. And then we have 2, 2, 4, 4, tetramethyl, and we can squeeze it all in there, pentane. So this is our full name for this compound, 3-ethyl 2244 tetramethyl pentane. And we're also asked to draw the Newman projection for this. So let me erase some of these markings here. And we're asked to look down at this angle, this line of sight. So let's identify our first carbon that we see would be here. And it has a methyl group coming down. And then we know there's also going to be two hydrogens pointed up. Our second carbon that we see, we have one tert-butyl group pointing up. We have one tert-butyl group pointing down to the right, and then we'll also have a hydrogen pointing down to the left. So let's see how we could translate this to a Newman projection. I'm going to draw my first carbon on a dot right here, or my first carbon that I see, and then I know I have hydrogen up to the left, hydrogen up to the right, and down I have that methyl group. So we can draw CH3. My carbon in the back, the second carbon that I see, I have pointed straight up, I have a tert-butyl group, and then I have down to the right, we said, another tert-butyl group, and then down to the left, we have our third group would be that hydrogen. So these are the, or this is rather, the Newman structure, and this is the name for this compound.